Hello, very warm welcome. Today we are looking at another LeetCode question, which is swapping nodes in a linked list. So here we are given a head node and an integer k. We need to swap the value from the kth node from the beginning and kth node from the last. So and we need to assume that okay, the index start from 1. So if I look at this array, right, which contains this linked list, right, which contains 1, 2, 3, 4, 5, and the k value is given as 2. So that means this is 1, this is 2 index, this is 3 index, this is 4 index, this is 5 index. What I'm saying is case 2, I need to pick the second index from here, which is this one. I need to pick second index from here, the kth value from here, and I need to swap this, right? I need to swap these values, right? So the question is fairly straightforward. We need to swap the values from the kth, from the beginning and from the end. And how we are going to approach this is we need to keep a tab of. First, we need to find out what all those nodes are. We need to find the kth node from the beginning, kth node from the end, and ultimately we need to switch the values. Now, there are multiple ways to do that. First, let me try a simpler approach wherein I'll use a hash map. I'll use a dictionary to kind of keep a tab of the index and the node. And once I have those indexes and the nodes, I'll pick the kth node and the n minus k, where n is the length of the linked list minus kth, right? So that will be your kth node from the end. Let me quickly pen this down. What I'm going to do is first I'll create a dictionary, which is say I'll create it as index comma list node, where my index will be a key that at a given index what is the node which is present. My dt is equal to new dictionary int comma list node, right? And what I need to do is I need to iterate through all the nodes. So let me create a head node. Now what I'm going to say, right, I need to iterate through all the values in the linked list and keep on inserting into the my dictionary. So what I'll assume is my index starting index is 1. I'll say while my tmp is not equal to null, right? And until it is not equal to null, I'll say my dt dot add index comma tmp, right? And I'll do index plus plus and tmp is equal to tmp dot next. So in a way, by the end of this loop, if I have say linked list say 2, 3, 4, 1, I'll have a, my dt will contain something like this. Key value pair, it will contain something like this 1, and it will contain a value which is say 2, 2, it will contain a value of say 3, 3 value contains 4, and 4 values contains 1. So this is my key, this is my value, right? Now if someone says k is equal to say 2, right, I need to take k is equal to 2. Okay, I got the third node, and k the maximum value in this is say 4, which would be anyways being held by index counter. I'll say k minus the index minus k, which will be equal to my swapping value, which will be this one. So I'll have 3 node and a 1 node, 4 node, which I need to swap the values for, right? So with this, now I need to find out the last node, which I need to say the swap node index, which will be equal to index minus k. Now, what is the node which I need to what is the node which I need to swap? So that we say where my first node which needs to be swapped is my dt of index k, and what my second node which needs to be swapped is my dt. This will be last, right? I'm just fetching those values from the dictionary on a given index. All I need to do is swap the values. So what my value will be, and int say temp val is equal to my first node dot val. Now first node dot val is now equal to my second node dot val, and my second node dot val will now equal to temp val. Ultimately, I'll return the head node. I hope you understood this. All I did is swap the values which are present for a given indexes. So I anyways found those two nodes. I just swapped the values and returned the head node. Let me run this. last and temp node doesn't exist. Where I'm picking last. Oh, so this will be swap node index. What is this? Temp file doesn't exist. This is this one. Let me run this now. Sorry, that was a syntactical error. I just out of flow I wrote last. So this got accepted. I think we got the expected result 14325 14325. Let me submit it. Cool, it got accepted. Now, if you see, the problem with this solution is that I'm using an O of n of extra space of the dictionary, and question may be kind of further. Uh, the interviewer may go ahead and say, okay, how can I improvise this without using O of n space? I should do it O of 1 space, right? Now, again, what we need to do here, right, is if I'm looking at this linked list, say 1, say 2, say this 3, and this is 4, right? So if I have two nodes which I'm looking at it, right, I need to first find the first kth node, right? So I'll say I'll iterate through this list, and I'll say, okay, this is my slow and this is my fast, right? I'll say, okay, if I'm iterating through the list until unless I find a k, I'll move forward with the fast index. So I'll say, okay, k is, I'm at this index, k is not equal to 1, k is, now here the k which is given to me is k is equal to 2, right? And index, you can assume the value in index for the time being same, because this will be 3, this will be 4. Now if I reach here, that means my fast node has reached the kth index. I can store this. I got this value in my, say, first node. First node now is equal to my fast index. Now what I'll do is I'll have my slow which is still pointing to this place, my fast being pointing to this place. Now I'll iterate further until unless my fast node becomes empty. Fast node is not equal to null. Let me make it a bit more simpler, right? So I have 1, I have say 2, I have say 3, and I have say 4. Now I'll have slow comma fast, right? First I'll move until unless I'm reaching the kth index, right? So I'll move my counter until unless I'm reaching the kth place. So my fast is at this position now, right? My slow remains at, you can say, head location, which is at 1. Now once I found this, right, I store this into my, say, first node which needs to be swapped. So this is stored now. Now what I'm going to say is why my fast dot next is not equal to null. So idea being, right, I'll again move fast forward the next steps, and I'll move slow accordingly, right? So by the time my fast reaches at this stage, my slow will be at this place. Why will be that be? See, slow is my at my head location, right? Now if I do my fast dot next, I'll reach at this position, and where my slow will be? Slow will be at second position, right? So now my slow is here, my fast is here. Now again I do a fast plus 1, so that means my fast will be at fourth location, and my slow becomes at this position. So in a way, right, you are seeing with this two pointer approach, what I'm trying to find is my slow is reaching to a n minus k position where I need to do the swapping, right? So let me pen this down, maybe post that it becomes a bit more easier. So what I'll have is my list node says slow is equal to, say, head, and my list node fast is equal to head, right? First I'll iterate through all the values until I reach a index case. What I'll do is for I is equal to int I is equal to 0, I less than k minus 1, I plus plus. What I'll do is I'll say my fast is equal to fast dot next, right? I'm first moving my fast counter. Now once I'm outside that, what will be my first node will be? My first node will become the fast index. With me with now till now we just followed what we just did not. We just followed what I just explained. Now what I'm going to do now is I'll say, okay, why my fast dot next is not equal to null, I'll move my slow pointer again, right? So what will now happen is my slow will be equal to slow dot next, Now fast is equal to fast dot next, right? So with this, as in when we are moving forward, just because my fast was at the kth position, by the time I'm reaching the end, so if I'm looking at 2 from the beginning, it will, and I have total 4, by the time it reaches the next end of the array, my slow will move towards the kth array from the last, right? Because this difference, so my slow was here, say fast was here, right? So 1, say 2, say 3 and 4. This difference was 1, right? This difference was overall, if I look from zero counter, the difference was always a 2, right? The moment my fast reaches the end, my slow will always be this difference back. So that means if you see, right, the difference between slow and fast was k. So the moment fast my reaches the end of the array, my slow will be n minus k position, right? That's the intent here. So once I'm outside this, right, my second node becomes my slow. With me, right? My second node becomes slow. Now once I have this this swapping will remain the same, and again this simply return the head node, right? Let me run this now and see what is happening. Still judging. This was with respect to previous result. I got expected result. If you see 14325, 14325. Let me submit it. It got accepted. Cool. So if you see that this will be a bit more faster, and this will be done in O of 1 space solution, right? And my overall time complexity will remain O of n, where n is the number of nodes in the linked list, because we are anyways reaching the end of the node using the fast counter, right? So if you see that this is kind of a sliding window problem, wherein I found my first position where the k node is. Once I found that, I just moved that window forward. The moment my fast window reach the end, my slow window will be at the n minus kth position, because the difference between slow and fast will always be equal to k, right? With this, I'll end this solution. In case you still have any questions, any doubt, please do reach out to me in the comment section. In case you like the explanation or are new to the channel, please do like the video and subscribe to the channel if you're very new. Thank you guys. Thanks a lot.